All right, so we got one more example to make sure we feel good with the calculator. This is a good example that's been a previous test question. So in this example, we're given a back-to-back stem plot showing bowling scores for males and females in the finals of a national tournament. Then we're asked to find the best measure of center and spread and then calculate these. So this question is really getting at 4 different things. 1, can we read a stem plot, especially a back-to-back one? 2, do we know what measure to use, when? And 3, can we actually calculate that measure? So this is doing a whole lot of work for us, this one problem. So let's go ahead and start with reading a stem plot. We've seen this before. We talked about it with the football data, right? This stem plot means that the women's scores, if I wanted to write them out, 238, right? This 8 gets glued back onto that 23, 239. Then we have a 240, and a 242, and a 248. So that's one piece. All right. Second piece is what type of center and spread to use. And this comes down to what we've been talking about, but we haven't summarized. Looking at the shape of our distribution, because we had different measures to use, whether we had symmetric data or we had skewed data, right? Our data with outliers. We had problems with outliers. And then also, do we know our measures for center versus our measures for spread? So we had symmetric data. That meant our data was beautiful and pretty. This is when our measure of center we want to use is the mean, right? Because if we have screwed up data, skewed data, or data with outliers, that's when we want to use the median, right? Just like we saw with that realtor. Versus spread, right? How spread out is our data? Well, what goes along with median is our IQR, because it's the median of the upper half minus the median of the lower half, right? It ignores the extreme values because it only looks at the middle 50%. Versus for symmetric data, we had 3 possible options: variance, mean, absolute difference, but we said that most of the time we're going to be talking about standard deviation. That's my favorite, and it's what we're going to see again and again in this course. So this is a little 2x2 table that we're testing with that second piece, what to use when. So for the females, their data looks pretty dang symmetric. So your choice of center and your choice of spread should be your mean and your standard deviation. For your males, we have, look at that male data, come back, scroll. Our male data is very, very skewed, right? So we are definitely not, my thing is refusing to cooperate. We are going to be using the median and the IQR. Now, one thing I want you guys to do is quickly decide which way our male data is skewed. Is it skewed to the left or skewed to the right? I'll tell you the most common mistake, I wish I could turn my page, but I can't, is to turn the page and say that this thing is skewed to the right, because the values, if you turn it so that the hump is at the top, are to the right. But if you actually look at where this tail is, it's towards the smaller values. So this particular data set is skewed to the left. And then it's just a matter of calculating these things, using whichever calculator you want. I would highly recommend you just give yourself a test with the calculator now that we've tried it to see how you do. I will go ahead and do the 84 if you want to watch it. Again, you really don't need to if you feel comfortable with the calculator stuff. All right, so I'm going to work through this with the graphing calculator. So first thing we're doing is the female data. Calculating the mean would not suck by hand, but calculating standard deviation by hand would be a beast. So I'm going to go ahead, stat, edit. I got to clear out what's in there. Clear and enter. I'm going to type in all this female data. Yeah, no, it's very exciting. Like I said, this is what gets me the YouTube viewers, or rather hours of engagement or something, because you guys are stuck here watching me type crap into a calculator. I'll go ahead and pause this, and through the magic of television, we'll be done. And voila, they're entered. So if we go to stat and over to calculate, I can do my 1-var stats. And I'm going to keep my stats wizard off because I hate it. I am a stats wizard. I don't need a stats wizard. I'm just going to press enter. Remember, all my data was in L1, so I'm good to go. And now we're ready. We got our mean, our mean is that x bar, which according to this is 256.86667. I hope. I can't keep things in my brain that long. Yep. Rounding to my 4 decimal places. And then my standard deviation, remember, is the SX. So that is the 14.6427. 14.6427. And this was a little SX. Perfect. So that's mean and standard deviation. I would recommend you still, unfortunately, suffer. If you want to suffer through this with the male data, because it reminds you how to clear your data set out. So we're going to do the same thing with the male data, except we're finding median and IQR. So again, I'm going to have to go back here, back to stat, back to edit. I'm going to go up to L1, press clear, press enter, and I'm going to start entering all that male data. There isn't anything for the 23, right? So do not put 23 in here. Nobody rolled a 23. That just means the lowest men's score was a 240. And again, I will pause you so you don't have to watch me type all of these in. All right, so 20 minutes later, I have entered all of the male data, and now I'm just going to go back to stat, over to calculate, still one variable stats. And just don't forget that you scroll down and you're going to get all the information you want for skewed data. So we can see here our median was 278. 278. And our IQR, we have to calculate as Q3 minus Q1. Q3 minus Q1, which looked like it was 286 minus 268, but I will confirm. Yep. Oh, poor brain. I think that's 18. It's been too many damn videos today. I can't remember. 286 minus 268. 18, hooray! All right, so that's using the calculator. 5-number summary, by the way, is the 5 numbers that divide your data into quarters. So all of these are pretty easy to find. We know how to find them by hand, and they're the final 5 numbers in the calculator. So in that calculator, I could go ahead, bring back up my Wabbit, and it's the final 5 things. 240, Q1, 268, median, 278, Q3, 286, and then the max score that somebody scored in that tournament was a 289. Perfect. So this divides your data up into quarters. So that means basically the same number of people scored between these 2 numbers as scored between these 2 numbers. Doesn't matter that these are only 3 apart and these are 28 apart. There's still the same number of people in that range for each of them. You can even go ahead and look at this on the data set. And hopefully I'm not lying. Between 240 and 268, there were 2 scores, versus between 289 and 286, there were also 2 scores, right? If you think about these things in order. So just pointing out, that's all this does is divide your data up evenly. You could even look at this last one. We've got, it's doing the same thing over and over and over again. All right? So we get to move on. Oh no, I moved things. This is terrible. Stop.